Welcome to Nerd House Geeks. We're going to continue talking about what is a class, and we're going to get into properties and encapsulation. Here's what we'll cover in this video. Encapsulation, give you a definition of encapsulation. We'll talk about access modifiers, properties, read and write properties, read-only properties, write-only properties, and auto-implemented properties. Now, one of the things I want to make clear at this point of the video is that this is a lot of definitions with some focus on demos. So I'm gonna, when I reach that part where I'm getting to the access modifier, you're gonna find that kind of lengthy, but bear with me, it's totally worth it, okay? So we jump right into the definition of encapsulation. The action of enclosing something in or as if in a capsule. In the definition of encapsulation in C#, and we'll get right into the details here now, is it describes the idea of bundling data and methods that work on that data within one class to hide the internal representation or state of an object from the other classes you may have. So when you're writing that code is going to put the representation, the state of that object into a sort of a capsule. This is also known as data hiding. Okay, so we're going to get into this data hiding. Question is, how do we hide data in a class? And we do that through what we call access modifiers. This is a list of our access modifiers: public, private, protected, internal, and private protected. I'm going to attempt to explain them, but once we get to internal, protected, internal, private, protected, I go, you know. But these modifiers determine what type of access code will have to the data in the class. This is why encapsulation is a fundamental principle of object-oriented programming. The variables or data of that class are hidden from any other class and can be accessed only through any member function of own class in which they are declared. Meaning, if we don't make it accessible, no other code can get to it unless we say it can. And surprisingly, when we go back to this slide, it describes the data, the idea of bundling data and methods. That's all that means. You know, sometimes you have to go through all the scientific definition. So the first and easiest one the most popular one is the public access modifier. Okay, the public keyword is an access modifier for types and type members. Public access is the most permissive access level. There are no restriction on accessing public members. All right, let's get to a demo. Okay, now we switch back to our project where we're doing all of this. As you notice, we created our domain class, our domain project, and that's where we have our classes. Okay, and we had created this guardian class and just kind of rushed through it real quick. All right, so now what we're going to do is create a brand new class in this project. Take your time, load it, select, and we'll name it the monster class. And so go ahead and fire away. Please don't take forever. So what is very interesting here is the way this class was created. It doesn't have an access modifier on it. So this will give us a nice chance to go ahead and play around with this. Okay, and I'm doing this all on the side of the MVC. So right now we have the Guardian class, and it resides within this domain. And the domain is where you keep all your objects and all your classes and your business rules when you're creating business apps. And we're going to turn this posh into something. So here we have the monster class, and it's also located right here next to the Guardian class. So the thinking would be like, hey, both of these guys are here, we should have access to it, right? I mean, that's the thinking. At least that's what I'm projecting on you to think, because it makes sense. If they both exist in this project, they should both be available. So we're going to go ahead and create another variable, and we'll call this player2. Player is equal the new, and what is going on? This is where the access modifiers become so important, because we cannot see it. And it's because we didn't give it the ability to be seen. Now if we look at the Guardian class, we could tell right away, wait a minute, at its highest level, it's public. Okay, let's make it public. There you go. Should be able to see something. All right, so let's go back over here. We have the little green thingy. So we'll go through it all again, and we should get a different experience now. Oh, there it is. Oops, sorry. Semicolon. So that there is an example of how those declarations determine what you get to see. The reason that's important, it prevents people from writing code that touch things that you don't necessarily want to get touched. That's the whole thing about encapsulation. Hiding. Yes, and you will get it on every little junior level interview they have out there. So, just to be clear, that was not an example of encapsulation. You know, that was an example of a public access modifier. We weren't able to see this until we got this declaration saying, hey, make this class visible to other classes. Okay? Now, we're going to go to the next access modifier, and then we're going to revisit encapsulation. I love this part. So after showing you an example of a public access modifier, and we enter that demo, now we're going to look at a private access modifier. Private access is the least permissive access level. Private members are accessible only within the body of the class. Okay? So let's get to a demo of that. All right. Let's go to the Guardian class. We're going to go to, monster class. We're going to create a private variable here. All right, an integer. And we're going to use life, the life total. We'll put in life total here. And now we want to initialize the value. So I do the underscore life total, not me, but commonly in development, when you see the underscore life total, That underscore means locally defined variable. And now Couture, as you know, that creates your constructor. And probably want to switch my life total above my constructor. And we'll put a default value here for life total. So if you don't specify one, it automatically comes with life total. And I think a good number would be what would Magic the Gathering do? 20 life. We'll go with that. Okay. And we'll create another constructor, and this one will allow a programmer, us, to be able to set that life total when we're initializing the object, which we discussed in our previous video, and it will be whatever we pass in as that life total. Excuse me, sorry. All right. Okay, so we'll go back to the home control. We have our layer 1, and now we want to, no, we're not. We want to play it 2. For the life of me, I don't know why I'm copying and pasting that. Okay, so player 2, because that's the monster, that's the class we updated. As you can see, we don't see those variables. You know, it doesn't show up in our list, so we can't even assign it. The compiler, the IntelliSense won't even allow us to read it in this case, and that's because it's private. So we have access to all the public. When you were looking when I did the Guardian class, we were able to see all the properties for player 1, but player 2, none of it. So we'll go ahead and use the second method here, which is the life total. That's the one we decided that we're going to pass in whenever we instantiate the object, which that's doing, creating it in memory based on the blueprint of the class, of course. And what I'm doing here is now, this allows you to see, this is a best practice, so that, you know, can you imagine reading this code and trying to figure out what a 10 is? You know, but with that, it allows other developers to follow the code and be able to understand what's going on. Good practice to have, especially when you're working with multiple developers. So we were able to see all the public properties in one. And I think that gives us a good clarification right there on the difference between public and private. And from there we can now jump into understanding that encapsulation. See, that life total is not accessible by any code outside of the class, only within the class. And this is an example in the form of encapsulation, where you can't touch the data. So we're going to get into that and talk about these access modifiers. And but once you hit public and private, you can begin to understand encapsulation right away. It just makes sense right away. So what we're going to do now is create a property. All right, I'm going to type all of this out. All right, here we go. What am I done over here? Okay, cool. All right, so we're gonna create a public property because we do want to know what uh, the life total is, and it's an integer, so we have that type, and we're gonna call it life total. They have the same name, but you see that this one has this little underscore. It's kind of convention sometimes, you know. It all depends. People like it, hate it. So I'm using it that this underscore means it's local and private to the class. And then this is a public property, accessible to everybody. So this right here is the property. Okay. And so, well, I probably put that in too early. All right, that's the property part of it. And now a property has a get and a set method. Get and a set component method in it. So here's the get. And in there, it's very simple. We want the life total. In that get, we want to return some method, life total. Oops, sorry. And kabab. So that will, when we reference it, we know that it's public, and we know that we've given it the ability to get a value. And in this particular circumstances, it gets us the life total. Now, we would like to be able to set it directly here. And that, we go reference the local variable, the life total, and give it and that's how you set, that's our set method. And that's how you assign a value to it. So this value keyword is going to be whatever value someone tries to assign to life total. So when someone goes player1 dot life total equals, that value will automatically be assigned here. Okay? Alrighty. So a few things we need to verify. Kind of already know where this is going. All the smart guys here. We'll just focus on player 2. That's the monster. And boom. There we have our life total. And we'll create just a variable down here equal, I don't know, life. And that's it. So we're going to put a breakpoint here before it tries to display a view that hasn't been designed yet. But we should see that this life total is what it is and how we assign, what we assign it to be. So we're just going to hit run real quick. Bum, 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 bum. No need for you to wait for all of this. Okay, so we hit our breakpoint here. And our life total should be, it is 20. So we assigned it 20 here. So that's our life total. And that's when we only run this, when we're creating this class in memory, we're running this constructor, which by default says, hey, we tested this in the other thing. Hey, set our life total to 20 automatically. Let's just say this monster is not really that powerful. this particular monster, I don't know, it's a small goblin. Okay. So we're going to run it. And not required. All right, moves a lot faster. And there's the life total of 5, which is how we instantiate the life total from within this so right there you're seeing an example of encapsulation. We have something that is not accessible to all our classes. We cannot write code to directly affect that. You could see this being very important as you're building programs and for other people to interact with the code. So it's protected. It's encapsulated. It's encapsulated inside here. And there's only one way to touch, 2 ways to touch this. And actually, we have its default behavior sitting right here automatically. Then we give you a one-time on creation time to set the power to any life total that you want. But then we also give you the ability to set the value here, assign it. So not very protected. We have all types of way that we're giving you access to it, but you cannot write any code to access it directly. So we're now going to see, can we assign it through, so we're going to set that to 5. Okay, and then we're going to go ahead and say equal, oops, what did I do? I guess when I build it, I will see what, the 30. So even though we build the object when it happened 5, we're going to go ahead and assign it to 30 because we can. So we're going to run it again. It's going to build a little faster now. Yes. Here we go. All right. So we set it to 5 when we initially started. Then we said, forget that. We're going to set it to 30. And the life total is 30. So even though we encapsulated this life total with inside of the object, boy, did we make it very accessible for us to make changes to. I think that's driving the point home overdone. And that's encapsulation. We have these private variables, things that we don't want everybody to touch, but then we start defining how it's going to be touched and what rules and regulations that we want to apply when it's going to happen. So let's go ahead and stop this. Interesting how simple things are, and you can see demos of stuff. That's encapsulation in a nutshell. But we're seeing how these access modifiers are directly tied to encapsulations. So right now we're going to go into protected access modifier, and a protected access is accessible within its class and derived class instances. All right, so explain what that means. But this is just going to be the trend of it. Each one of these modifiers have their particular definition. We're going to talk about it, and then we're going to simply demo it. All right, here we go. All right. Let's go ahead and demo protected. So I'm going to close this up here. What we're going to do is add another class to our domain. Okay, we're going to name this a black troll. Okay. All right, here we are, black troll. We're gonna make it public so that we can reach it. And we're gonna have it derive monster class. Okay. Now we're gonna take our favorite property here. Once we change this, this is going to be, we're gonna see some things go on now here. Okay. Got a problem now. Total life is inaccessible due to its protection level. Whoops, what is that? That looks like a mess up on my part. Okay. So we are going to, it can only be used by the class that derives it. Okay, so what we're gonna do here, I'm gonna copy this little code snippet. I hope this helps and makes it easier to understand. Okay, so it can only be referenced by the class or it's derived from. So as we can see already, by that method being protected, and it's not derived from here, it's not accessible. But when we look at this code here, we don't get a problem. So it can only be used by black troll. There are instances when in programming that's naturally how you want it to occur. So this won't work. So we're going to go ahead and comment this out. Boom. And what we're going to do, instead of having a monster here, we're going to put a black troll. Voila. How you like those apples, huh? Then we're going to make a copy of this for testing purposes. And player 2 won't give you because it's taught. Try this. So let's try this is just a method in which the back troll inherits from monster. And let me be very clear about this too. Let's go ahead. You're gonna like this. You're gonna put the mo and you monster. It can't even be used within its own. So you see, you get that? I'm using the monster class, right? And I'm creating this in memory. And when I go ahead and the IntelliSense doesn't even show life total, because only the derived class can manipulate it. It's crazy. Like, this won't work. That will give you a compiler. If I try to take the same life total and stick it here, which is perfectly legal in all the code, just won't work. It's protected. It can only be used by the class that derives it or classes that derive it. So I hope that helps, you know. And if you can see, if we uncomment these, yeah. Just not going to happen. It's crazy. Well, I hope that explains it, because running it will make a break. You know. But if we go here, let's comment that out. Black troll, monster, I changed it to protected. Let we go here, we run it, and we should get whatever we set it here in control. To 10. Yeah, let's run it. Set the breakpoint. Okay, that's fine. Hopefully that takes a long to build. Wow. And this one was always kind of weird for me. Come on. Don't make me have to skip ahead. Okay, good boy. 10. Man, I hope that explains how the protected access modifier works. I love it. I love it. Programming can be very boring to learn, but boy is it interesting when you learn it. The things you can do, and yes. Thank you very much, man. That was fun for me. I like showing that. Totally a nerd out moment. So, very interesting. A protected access is accessible within its class and by derived class instant. Amazing. We went through the demo already. Internal access modifier. Internal are accessible only within files in the same assembly. Demo time. Okay, so here we go. We have the black troll. We have all of this. We can get, let's just leave it commented out for now. All right, so internal. And so internal is only accessible within that assembly. That right there is an assembly. That entire project is its own separate assembly. So we're going to demonstrate this again. These concepts are really easy to understand sometimes. I like it. And we'll create what we call the black angel class. Okay, and we're going to just go ahead and decorate it with the internal. Okay. We'll stop right there. So that means that this class is only accessible within this assembly. Well, let's see if that's true. Let's go ahead and prove it. Home. Okay, so as you can see, this class is in here with all the others that we've been referencing and doing our testing with. And if we went ahead and tried to create, we said third player, okay? 3 equal a new BL. Oh, no way. If we went back and made it public, right, that's great. If we made it public, again, if we went to this IntelliSense, we'd pick it up, and there's our black angel. When it's internal, it will be only accessible within this assembly. There are programming needs when that is the case. Okay. I'm very suspect about using it, but I'm here just communicating the information. Don't really go in this direction a lot, but you need to know what it is in case you run into it or have a need for it. I have varying opinions about this stuff, but right now we're not worried about my opinions. Just, hey, yeah, there it is. I hope that easily communicated how that works. That will be accessible only within this assembly, not outside like these guys are. Okay? So yeah, we have a good understanding of the internal access modifier. Hope I did a good job explaining it and showing in demos. And it brings us to these combo type declaration. This is protected internal access modifier. A protected internal is accessible from the current assembly or from types that are derived from the containing class. And so because we're showing protected and internal separately, they're combined, they can coexist. There's no conflict there. I don't know if I need to demo it because we know what the protected and the internal together do, and we know how to decorate function, properties and methods with it if that's what we needed to achieve. Same thing here with private internal access modifier. The private internal is accessible by types derived from the containing class, but only within its containing assembly. I mean, once we explain that, I think we're all good there. There's no, you don't need another demo for that. If you do, just let me know, but I think we got it. So let's talk C# properties, which is kind of a joke because that's what we've been doing a lot of, mostly C# properties. A method here or there, in the form of constructors. We use to show these properties and how they use to create encapsulation. And so with that, we have one more thing to touch on properties. Now we know properties enables a class to expose a public way of getting and setting values while hiding implementation or verification code. But there are also different types of properties. And I'm not sure if I'm saying types is the right way, but you'll get the gist of it here. We have properties where you can read and write. We have read and write properties. We have read-only properties and write-only properties, which is rare, but it's doable. And then for very simple properties, we have the auto-implemented properties. So I'm going to really take time here, not like in length of time, but some properties may have like validation code in them, for ranges and stuff like that. So as I go through these different types, should be pretty easy. Gonna try to knock them all out in one shot, and I don't know, create us a demon or something. All right, so let's head over and let me demo this, and then that should be wrapping up this video. Okay, so I'm going to go back to Black Angel, who at this particular point cannot be seen outside of this assembly. All these other assemblies will not be able to see that code. Close the project. Wow. And we're going to change that. We're going to make it public. Make it visible. Now we're going to create some private members here. All going to be integer. And we'll pull shields. And we're just gonna go shield. I want the space after I make this. Attack. And the next one will be. No, I shouldn't have taken both. Is it being life points or life power? What are I being used? Life total. We'll go with that. Keep the running theme. Life total. Okay. Okay, now you see this property here. We're just going to go ahead and kind of cheat here. And I'll just keep copying it over. So for the life total, done. And this one will be for shield. Not shield. We'll go block. That's what I like. Attack and block. I like block better. So we'll let it be block. Attack, block. Then attack. We'll find a way around all of this as well. Alrighty, this is still distracting to me because we're over it. But anyway, so 1, 2, 3, we have 3 properties here. I'm gonna go back to our controller and we're gonna get rid of the black troll for now and go with the black angel. Ding, 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 ding. And it doesn't have that power. Okay, so we're gonna put a constructor in here. And what the constructor is, I explained it in the previous video. You just type that in, CTOR, and then double tap and it'll create your constructor. And in our particular case, if it's not set, I'm going to start off with 20 life total. Magic Gathering has its impact on me. And this will be, I don't know, 2 block. Yeah, I'm there. For an attack, we'll do, so depending on how it all comes down, block and attack, it's a 3/2 creature. Because I think of it that way, I'm just gonna put sorry. It's a 3/2 creature. Can't block. Whatever is over, it takes away from the person's life. Alright, we'll deal with that later. So the first one that we're going to tackle has already been tackled. We're gonna have a property that is read and write. And we're going to make that the life total. So, public, here you come. Okay, we're gonna make them all public to get this example like we want. All right. So this means that we can add and take away from the life total. Whenever we assign this equal, that value that we assign here will go in and be assigned to your life total. But we may not want it to work like that, you know, because we want life totals to be able to grow, you know, not just so what we're looking at is it's going to be cumulative. So when you assign a life total of 5, what it's really going to do is see what the value of this is and take it away and add to it. If you assign it a -2, then it will subtract away from the life total. So it won't just set it to one value whenever we do something. So we'll do that for now. So it's a read-write property. It's a read-write property because you have the get and set. Well, in that case, that's all it takes to make it a read-only property. And so we'll demonstrate how that's going to go wrong. So we already have this dot life total equal 5. For us, that's a boost of 5. Okay. Sorry, I don't need to do you anymore. We don't need that assignment. So when this executes, this life total will be 5 more than what we started. But now, when we go here to block, compiler error. So block is a read-only property. If we do this, I feel like an idiot the way I'm typing today. No, 2. That will give us the value. Pilot error. Won't even bill because it's read on. It's write only. So, several things we want to check right now when we're running this. Let's go. And it takes too long to compile. I'll speed it up, but it doesn't. So this is before we assign the value of it, and the playlist is 20. If we hit F11, oh, will it? Let us in? 25. That did exactly what we wanted to do. The block is 2. We knew because we can't. And the attack before it gets inside is now. Come on, give me a little pop-up. And we assign the attack, but it doesn't. We don't get to read it because it doesn't give us that information. It doesn't have to get. We only get to write to it. We don't get to see the data or the value of that data. We just write to it. So that's behaving exactly as expected. We can't write to this. We won't get this read because the compiler knows right out the gate that we don't have a get to go get the value anyway. Now the auto implemented property. If you don't have logic like this going on and you just simply, hey, just assign it. So we'll create another. We're not even going to create it. We're just going to auto implement. PRO. And this is like the shortcut way of doing this. You just hit tab. And so this is the auto implemented property. And this is your points. And you don't have any logic in there to behave differently. It's not just read write. This is just a simple points property. Whatever you put in there, it goes and does all of this on its own via the compiler. It does it all on its own, and it just looks like any of the other properties. So we'll go to player 2. Points 100. Probably an equal sign would help, just maybe, Very important to the whole shebang. Oh my goodness, it's late. It's 11:42. Oh my goodness. Oh, so I really think I've touched all the subjects, and good riddance. I think you're ready to be done with me. Thanks for sticking in if you stuck in this long. All right. I think that's all of it. I think we've got it all. I'm going to turn it into some sort of very, web-based game. I haven't figured that all out just yet, but we're going to have some fun with this. All right, thank you very much. Hey, yo! 2021 has begun. Thank you so very much for watching these videos. Like and subscribe if you want to. I appreciate every way you support. Have a lovely day, night, just depending on what time it is in your part of the world. What else you want to say?
Listen, ladies and gentlemen, you gotta try the rides. This is what the hug is talking about. Hulkamania.